Hello everyone, welcome to the series of GPAT MCQ. Today's topic for discussion is pharmaceutical packaging. This is Tripti Parab. First question, benefits of packaging excludes option A, product identification, option B, product integrity, option C, product promotion, option D, product dumping. So the correct answer is product dumping, option D. Benefits of packaging include following: product identification, as the packaging help us to understand what type of product it is. For example, in pharmacy packaging, it includes like the product identification includes whether it is syrup, solution, tablet, capsule. Product protection, the packaging protect product from contamination. Product promotion, as it helps to increase the product and patient compliance. Next question, syrup pack in a glass bottle is an example of option A, primary packaging, option B, secondary packaging, option C, tertiary packaging, option D, none of the above. So the correct answer is option A, primary packaging. So there are three types of pharmaceutical packaging: primary packaging, secondary, tertiary. The primary is the one where the material or the pharmaceutical product directly comes in a contact with the packaging. Secondary, it is used to group primary package together. Tertiary, it is used to bulk handling and shipping. So basically in this above picture you can notice how the primary packaging is, and the drug is directly contact with the pharmaceutical packaging. For example, the syrup is directly coming in contact with the glass bottle, or the tablets are directly in contact with the plastic bottle, or the capsules are directly contact with the strips, etc. Move on to the next question. Lab instruments made up of which type of glass? Option A, type 1, option B, type 2, option C, type 3, option D, type 4. So the correct answer is option A, type 1. Type 1 glass is also known as borosilicate glass, highly resistant borosilicate glass. It is a highly resistant glass. A substantial part of the alkali and earth cations are replaced by boron and or aluminium and zinc. That is the composition of borosilicate glass. Suitability, it is used for parenteral uses, chemical glassware container for alkali sensitive preparation, and the borosilicate glass is normally used in laboratories. As a student, you might have seen it is written on the beakers or conical flasks that it is made up of borosilicate glass. The next question, water attack test performed in option A, type 1, option B, type 2, option C, type 3, option D, type 4. So the correct answer is option B, type 2. Water attack test. This is only for treated soda lime glass type 2 containers. Principle involved in this test whether the alkali leach or not from the surface of the container. So basically we are going to take a glass container made up of type 2 glass, and we have to check if the alkali is leaching out from the surface of the container or not. The process given below for the water attack test: the container are rinsed with high purity water, then filled with water up to 90% of its capacity. Autoclave all the containers at 121 degrees Celsius for 30 minutes. Cool, then decant the liquid and titrate the liquid present in that container with 0.02 normal sulfuric acid. The consumed volume indicate the amount of alkali leach from the glass. So basically, alkali is going to react with sulfuric acid, and the amount of volume consumed by the decant solution indicates the amount of alkali leach from the container. Move on to the next question. Most commonly used metal for packaging. Option A, aluminium. Option B, tin. Option C, lead. Option D, iron. So the correct answer is option A, aluminium. Let's understand why aluminium is most commonly used pharmaceutical packaging material. Aluminium, an element which creates a protective barrier which keeps the contaminants such as moisture, oxygen, light away from the medical product. As we know that there are certain drugs which are photosensitive, which get degraded when they are in contact with the sunlight. So you might have studied or have noticed on many uh, containers it is written that stay away or store away from the light, as the drug is light sensitive in nature. And when it comes to oxygen, the oxygen contact with the raw material or pharmaceutical material causes oxidation, which degrades the pharmaceutical product. This extends the shelf life of pharmaceutical, which makes them safer for the patient, and that is the reason aluminium is most commonly used, as it's provide a barrier against oxygen, moisture, biological, chemical, and even aroma, which keeps our medical product safe from the contamination. The PET, that is polyethylene tetrahydride, aluminium, and low density polyethylene, that is LDPE, laminate of foil packaging maintain their integrity. What is the meaning of integrity here? That is the protection of a pharmaceutical product from any kind of contamination. Aluminium foil pouches are an easy to seal pharmaceutical packaging, which makes our product even more consumer friendly for the patient who need to reseal them for the repetitive use. Move on to the next question. Product plastic interaction include option A, permeation, option B, leaching, option C, sorption, option D, all of the above. So the correct answer is option D, all of the above. Product plastic interaction includes permeation, leaching, sorption, chemical reactivity, modification, modifications in the sense of physical and chemical modifications in the properties. What is permeation? Permeation is the basically transmission of gases, vapors, or any liquid through the plastic packaging material, which can affect the shelf life of a drug. Permeation of water vapor from plastic container to the product can degrade the drug, and it also promote the growth of microorganism. Leaching. Most plastic containers have one or more ingredient added in small quantities to stabilize or impart specific property to the plastic. Problem may arise with the plastic when coloring agents in relatively small quantities are added. For example, the coloring agents leach out to the pharmaceutical product, and which can cause degradation or contamination. Next is sorption. This process involves the removal of drug content from the product by the packaging material. Sorption may lead to serious consequences of active ingredients in a solution. Sorption is mainly seen with preservatives. Chemical reactivity. Chemical ingredients of plastic container may react with the pharmaceutical product, which may can lead to pharmaceutical contamination. While the modification include physical and chemical properties which causes the contamination, for example, degradation of a pharmaceutical product, and which may hamper the shelf life of the product. So basically, these are the following interaction involves in product plastic interaction. Next question. Test for closure exclude option A, fragmentation, option B, dissolution test, option C, self sealability test, option D, penetrability test. So the correct answer is option B, dissolution test. Test for closures include penetrability, like we are going to check the product is getting penetrate from the closure, so उससे leaking का chances हो सकता है. Second, the sterility of test, मतलब जो हम closures use करने वाले हैं, they should be sterile so that जो हमारे product या pharmaceutical product को वो affect ना करे. Fragmentation test, like we are going to check the fragments present in that or not. Fourth, self sealability test, like we are going to check the product packaging, that is closure जो use किया है वो sealability मतलब वो proper seal हुआ है कि नहीं, because अगर improper sealing होगी तो it might can cause contamination of pharmaceutical product. While dissolution is performed for the pharmaceutical dosage forms like tablet, capsule, and it is not performed for closures. Next question. Speed of packaging is more seen in option A, blister packaging, option B, strip packaging, option C, both, option D, none. So the correct answer is blister packaging. Blister packaging shows higher packaging speed relative to the other packaging material. So there is like matlab may have they people have might compare the speed of each type of packaging, blister हो, strip हो, या containers हो, या plastic bottles हो. So in that cases, after studies या research हमें पता चला कि blister packaging is मतलब वो ज़्यादा फटाक से ज़्यादा इजीली हो रहा है and its speed comparative to other packaging is higher, and that is the reason we analyze that the blister packaging has more speed comparative to other. Blister packaging also helps to retain the product integrity because the drugs that are pre-packed in blisters are shielded from the adverse condition. So you guys have to remember the advantage and disadvantage of most of the packaging, whether it is plastic elements like steel, aluminium, blister, strips. You have to remember it for GPAT as well as NIPER purpose. Move on to the next question. Limit for soda lime in a powder glass test is option A 0.1, option B 0.7, option C 8.5, option D 10. So the correct answer is option C 8.5. So this is the test performed and where we can check the limits, like this is the chart and types of glass type 1, 2, 3, and the test performed for those glasses, that is powder glass test, water attack test. These are tests basically performed to check the alkali content present in the glass, and alkali को neutralize करने के लिए we need sulfuric acid. So basically the amount of sulfuric acid consumed has its own limit. अगर वो limit से ज़्यादा हुआ, so the glass will be discarded. And so type 1 the limit is 1 ml, the type 2 the limit is uh, 0.7 and 0.2 depend upon the size, like 100 से ज़्यादा है या over 100, like type 3 it is for 8.5 ml का limit है. उसके ऊपर अगर लगा so it means वो ग्लास में बहुत ज़्यादा अल्कली है and the glass should be discarded. To type 4 the limit is 15 ml. So these charts are very much helpful for the revisions, and this question can be asked in GPAT and NIPER. Thank you for being attentive. Stay tuned for more such videos.